Welcome to our video on AI in autonomous vehicles. In this exciting journey, we'll explore how artificial intelligence is revolutionizing the way vehicles operate, making self-driving cars a reality. From advanced perception systems to real-time decision-making, AI is at the heart of this cutting-edge technology, enabling cars to navigate roads, avoid obstacles, and adapt to unpredictable environments, all without human intervention. Whether you're new to AI or curious about the future of transportation, this video will give you a glimpse into the fascinating world of autonomous vehicles. Let's dive in. In this video, we'll take a closer look at how AI powers autonomous vehicles and makes self-driving cars possible. We'll explore the core components of AI that enable these vehicles to sense their surroundings, process vast amounts of data in real time, and make critical decisions like lane changes, obstacle avoidance, and route optimization. You'll learn how technologies such as machine learning, computer vision, and sensor fusion work together to create a vehicle that can drive itself safely and efficiently. We'll also discuss the current challenges in autonomous driving, from safety concerns to ethical questions, and what the future holds for AI in this rapidly evolving field. Get ready to discover the amazing technology behind the cars of tomorrow. What is artificial intelligence? AI is defined as the ability of a computer program or machine to think, learn, and make decisions. In general use, the term means a machine which mimics human cognition. Deep learning technology, which is a technique for implementing machine learning, an approach to achieve AI, is expected to be the largest and the fastest-growing technology in the automotive AI market. It is currently being used in voice recognition, voice search, recommendation engines, sentiment analysis, image recognition, and motion detection in autonomous vehicles. How does AI work in autonomous vehicles? 1. Simulating the computer process with the human intelligence. For example, whatever the human is able to do, think and react to particular situations, we are able to simulate the same thinking with the vehicles in the real time. 2. As the amount of information being fed into telematics systems grows, vehicles will be able to capture and share not only internal system status and location data, but also the changes in its surroundings, all in real time. AI perception action cycle in autonomous vehicles. A repetitive loop, called perception action cycle, is created when the autonomous vehicle generates data from its surrounding environment and feeds it into the intelligent agent, who in turn makes decisions and enables the autonomous vehicle to perform specific actions in that same environment. 3 main components of the perception cycle. 1. Component 1, in-vehicle data collection and communication systems. 2. Component 2, autonomous driving platform, cloud. 3. Component 3, AI-based functions in autonomous vehicles. This diagram illustrates the AI-powered architecture of autonomous vehicles, breaking it down into 3 major components. Component 1, in-vehicle data collection and communication systems. This section shows the various sensors and communication systems used to gather information from the vehicle's environment. These include LiDARs, short-range and long-range, for detecting objects around the vehicle. Electronically scanning radars and cameras, trifocal, traffic light, that observe the surroundings and traffic signals. GPS antennas, to provide location data. Dedicated short-range communication antennas that allow the vehicle to communicate with other vehicles or infrastructure. Supercomputers and data communication systems, for processing and transmitting large amounts of data. All this data acts as the input to the system, which is then sent to the autonomous driving platform. Component 2. Component 2, autonomous driving platform. This core platform processes all incoming data. It includes a memory unit with a database that stores historical data, road information, and learned behaviors. A control policy engine, responsible for making real-time decisions based on this data. For example, it decides how the vehicle should react to obstacles, traffic signals, or lane changes. The processed information, or action data, is then sent out as output to perform various driving functions. Component 3, AI-based functions in autonomous vehicles. This section highlights the AI functions that control the vehicle's behavior. These include automated drive and object detection, allowing the vehicle to drive itself and avoid obstacles. Voice and speech recognition for interaction with passengers. Gesture controls for additional input methods. Driver monitoring and eye tracking to ensure the human driver, if present, is alert. Mapping systems and safety systems for navigation and ensuring vehicle and passenger safety. In summary, this image shows how autonomous vehicles rely on a complex ecosystem of sensors, data processing, and AI functions to collect environmental data, make decisions, and control driving behavior. Semantic segmentation, the process of identifying and classifying objects from sensor data, is known as semantic segmentation. Detail, for human adults, they are trained to recognize patterns from birth. This is a slightly abstract concept. We see an image of a car and instinctively know what it is, even if we don't know what exactly it is. For computers, however, this poses a significant challenge. The system has to recognize that, say, a small change in an object property could determine an absolutely different class at first. This is an illustration of how a deep neural network classifies the different objects. For example, cars, cycles essentially, what it does is feed the data into the mass of interconnected neurons, each of which can have tens of thousands of connections to the others, and then compare the observed output to the target. Over successive iterations, the network refines itself, changing the strength of certain connections until the input exactly matches the desired output. Is there more to come? Artificial intelligence, especially neural networks and deep learning, have become an absolute necessity to make autonomous vehicles function properly and safely. AI is leading the way for the launch of Level 5 autonomous vehicles, where there will be no need for a steering wheel, accelerator, or brakes.